Hello everyone, welcome back to another video from the Winter Forest. Let's continue our LeetCode challenge. Today's question is called a danger game. In here, LeetCode wrote a beautiful story about the light to save the princess from the demon. Here represent the demon catch the princess on the bottom right corner. P represents the princess, and the light only can start from the top left. The K represents the light, and the light can move only right or down. And we're going to calculate what is the minimum healthy value for this light can carry on to save the prince. And the light, not the prince, the princess. And the light suppose had at least one value. 0 means the light is dead. And we're going to use the DP array to solve it. This is a pattern problem. I don't think it is quite difficult. It marked in LeetCode as hard question, but actually if you know the DP pattern and then you can find the sub question, it actually quite simple. And just draw 1, 2, 3, you're going to know how to do it. I'm going to change it to the pencil. And we're going to draw the initial thing. The input is negative 3, 3, negative 5, negative 10, 1, 10, 30, and negative 5 here represent the princess. And the positive number means you could add the healthy value, and the negative value means you're going to lose the value. After the lost value, your value cannot be 0, must at least 1, means the princess still alive, or the light still alive, sorry. And we're going to initiate the DP array, so you have the positions of 1, you have 1, 2, 3, 4, 5, 6, 7, 8, 9. If I say 5, position 5, so you have the P5. We're going to P6, P7, 6, 7, so the P8, and the P9. So you have a P1, position 1, position 2, 3, position 4, and the P position 7. And we're going to initiate and the same empty, going to have empty DP array over there. So you definitely have a two-dimension loop. Instead, in the end, we're going to return this value, but we start from here. So if we are start with the position 9 in here, then the minimum value what we need for this one, it is 6. Why? Because 6 minus 5 equal to 1, because I need to have 1 healthy value, keep the light alive. So if I move from the position 6 down from here, then I only need 5. Why? Because I could pick up 1, then when I reach the position 9, I could have a value is 6, I can pick up it here, then still arrive. For what happens if from here, in here, from the position A to the position 9, in here I only need 1 value, because when I come into here, I could pick up the 30 value, definitely can arrive in here, but I still need 1 value, otherwise if I'm 0 or negative number, means I already dead. Only come to here, we have 2 conditions. We're going to pick up, we're going to have, if we from 5 move to position, this is the P position, and move to 6, then move to the position 9, what kind of minimum value we need? In here, we need a loss 11 value. So the HB value in here, we at least need 15. Why? Because 15 minus 10 equal to 5. So from here, move to here. From here, move to here, need 15. And if we from here move to down part, if we from P5, then move the position PA. If I move from this direction, then going to rescue the principal at the position P9, then the HB value only need 11. Why? Because 11 going to loss 10 over there minus 10. It is have one value, only need one value come to here. So in this time, we compare which one is the minimum. Then in here, this one is the small one, so we pick 11. And the rest will do the same. And so it definitely here is 2 and here is 5. And then you move to here is 1, 6. And in here, actually, the result is 7. So you return dp 0 and 0. Actually equal to 7. And now we're going to write the code to represent this solution. First, we do edge check if this is empty. The length is 0. We just return empty. Return. You only need to remove just one. The first row, this is the edge case check, and then we go and find the whole, the deep, the danger of the length, then have the no length. Use the in. M. The first row, because it's now we init our DP array. The new array suppose DP array still is the same size. That's why we need to get M and M value. We're going to find this value, initiate this value. Just check if this is selective value. We're going to update it. Otherwise, it's stay the same. So if this is selective, make sure the left still the light, sorry, not the bright, the light alive. So we need to make sure this ladder at least have a 1 HP value. Otherwise, just won't going to change, stay the same. So now we're going to loop it. So for DP array, I think this is just like a pattern. Since this already populated in here, so skip this value updated. It's updated in here. I think I just use C. HP corner value, HP no value. This means that even just give the initial value or just give just the calculated value. Because you use this the maximum, you're going to pick up the minimum of this value. So the HP value is minimum of them. From here go down, maybe use D. And from here go right. From here go down, and from here go right. And if equal to this equal to the biggest one, you're going to just use the D for the maximum, because you're going to pick up the minimum of them. You suppose then you change this go down or go right. Which one is the smaller one? Choose the minimum one. Then you update the DP. And just compare the HP. If equal less than 0, then you update to at least 1, otherwise equal to the HP value. once the looping finished, just return the dp 0, 0. Let's run the code. Sorry. Yeah, it finished and it accepted. I haven't tested, submitted, see all of the scenario accepted or not. So just submit it and it accepted. Thank you for watching. Bye.